All right, so I forgot there was actually some more rules before we get to example one. So let's go ahead and do this part, and then we'll get to example one, and then do work and all that great stuff, the stuff that you love doing. So here we talked about again, we're dealing with r and theta. And with it, we already talked about having positive angles and negative angles and all that great stuff. Now, when it comes to our r, the r part, the r, with the r, if r, let's say if r is greater than 0, and we already know what that means. If it's greater than 0, it means it's positive. Then theta is the measure of any angle in standard position. So it's, and with this, to give you an idea, I'm going to write this part. That has the ray, OP, as its terminal side. Now, when you look at that, you're probably like, huh? What? Say what? I don't understand. So let's give you a picture of what we're talking about. We know here that when we deal with, I'm going to draw this right here just to do it. We know when we have our angles, we know this is like at 0, so 0 degrees, 0 radians. Either way, we know that if we go this direction, we have positive angles, right? And if we go the opposite direction, we have negative angles. It kind of works the same way with the R, kind of, sort of. When it comes to our positive, we know we have our polar axis right here. Again, this is our polar axis. And if it was to be like pretty much a positive angle, so R was graded as a positive number, that means that we're going with the numbers that are on this side that are positive, and we just make the angle come around. So here, it would kind of be like this. It's a positive R, so that means we're taking it around from this direction and going this way. So it's a positive R. And our point would be P and R theta. Now, to do the opposite part, if R is less than 0, sorry, if it's less than 0, then theta is the measure of any angle that has a ray opposite. OP as its terminal side. All right, so if it's negative, if the R is negative because it's less than 0, whenever we do this part here, you would say, okay, well, if let's say it was negative 2, let's say pi over 3. So with it, you're thinking, okay, well, we have one circle here, we have two right here. So if it's one, it's two, and the circle comes all the way around. I'm sorry, this picture does not look that great. But if it's negative, and then we have this here. So we will kind of come over to 2, and we'll come over to pi over 3. But because r is negative, and again, you'll have the line that comes across like this. Because remember your circle here, we have pi over 3 right here, and then there's a line that comes all the way across the other side here, and that's like 4 pi over 3. So what you would do originally would be, because it's a positive, if this is negative 2, it originally would be here, but because it's negative, you would do it on this side. So you do it on the opposite side. So when you draw your ray for it, it would be like this. This is your polar coordinate, the polar axis, and this is actually the ray you would do. And you would do at 4 pi over 3. Now that might be a little confusing, and it's okay. When we get to our actual examples, hopefully it'll make a little bit more sense there. So here, just giving you the focus there. If it's a negative r, you don't do it where the angle is, the original angle is. You're going to do it on the other side of that line. So you'll need to know what line that is, but put it on the opposite side. Okay? All right, so still might be a little confusing, but it's okay. So let's go to example 1.